Welcome, everyone. We're waiting for everyone to load on, getting close to the noon hour. Appreciate you joining with us today. Okay. Great. Well, we should probably get underway here. Welcome, everybody. We appreciate you joining us today for our webinar with Thermal Care on some process cooling. We're lucky to have three from Thermal Care today. We've got Jason Lehman, Mike Shoup, and Danny Thomason from Thermal Care. They'll be doing our presentation today. We've also got Michael Bacon from Hurley, who's a product specialist on Thermal Care, and Dave Greenheck um, working with us as well. We're grateful for your time. And with that, I'll turn it over to Mike so he can start us up and make some introductions. Appreciate it. Thanks, Mike.
Excellent. Thank you. Yeah, let's go ahead and get started. Good afternoon, everybody. Thank you for joining us today. We're excited to talk to you guys about process cooling and thermal care solutions. Start off, my name's Mike Shoup. I'm the Director of Product Management for Thermal Care. I've been with the company for 6 years. Before I was the product manager, I was an engineering manager in the engineering department. Before that, I spent 14 years at another refrigeration equipment company, and joined today by Jason Lehman. He's our industrial sales manager. Jason brings 17 years of experience with thermal care and a deep understanding of the wide range of industrial applications and their unique needs. So together, we're gonna walk you through some of the fundamentals of process cooling, and then some insights on our equipment and our solutions, and how we can help customers optimize their performance there. So let's go to the next slide, and let's start off by talking about what is process cooling and how does process cooling different from comfort cooling. So process cooling is all about removing heat from a manufacturing process or from manufacturing equipment. And it's used in various applications, including plastic molding, laser, CNC, food and beverage, chemical, medical. In fact, Thermal Care has over 50 different markets that we sell our equipment into. The key with process cooling is it requires precise temperature control, and often you've got systems that are running 24/7, and of course with a wide range of different applications, you get a wide range of set points with different flows and pressures required. On the other hand, you've got comfort cooling, which is what most people are familiar with. And in that, you're just maintaining a comfortable environment for an office or home or school. It's really focused on air temperature and humidity. And in those type of situations, you've got intermittent load. Your system's running on or off depending on how hot or cold it is outside. And it's not necessarily mission critical. If you've got a failure or your system's not operating uh, to the optimum efficiency, you're not losing product. You've maybe just got some people who are a little bit uncomfortable in the office. So you've got quite a difference there with the needs for process cooling. So now that we've kind of talked about that, let's go to the next slide and let's talk about what kind of equipment that we use in process cooling. Generally, if you're moving a bunch of fluid, you've got a big reservoir or a big tank that you need to cool. And to move that fluid, you're going to need pumps, right? To push the fluid through your system. If you've got an open tank, you definitely want to have a filter because you may have heat exchangers to isolate. If you want to isolate either your tower water or if you've got a glycol on one part and water on the other part you don't want to mix, you may have a heat exchanger in between. What really does the bulk of the cooling, the main heart of the process cooling equipment is the chillers, and we're going to focus on that a little bit. I've got it broken into 3 different types of chillers here. You've got central chillers, which are essentially dedicated to cooling a tank. Generally speaking, our central chillers don't have the capability to have its own pumping or its own reservoir. They're just providing the cooling for a large system. Then you've got what we call a package chiller, which does have the ability to incorporate some of those other things. So a package chiller may have onboard pumping, or it may have an integral tank connected to it. And then you've got the portable chillers, which is essentially the same as a package chiller, but in the smaller capacities, we can put them on casters and make them so that they can move to different parts of the plant and service different machines. Now, depending on what type of chiller you have, you're going to need to reject that heat somehow. So you may have fluid cooler or a cooling tower. And if it's an air cooled, you may have a remote condenser. So as I said, we're gonna go a little bit more into the chillers. Let's go to the next slide here and let's look at essentially how a chiller works. Right in the middle there, you've got the evaporator, which is essentially the key cooling component of the chiller. On one side of the evaporator, you've got your process fluid, probably water or glycol. And on the other side, you've got a low pressure vapor refrigerant that's cooling your fluid, right? So that's where the cooling happens. And then as that low pressure vapor leaves the evaporator, it moves up there into the compressor. Compressor is like a pump. It's going to take that low pressure gas and add pressure to it to change it to a high pressure gas. And it keeps the fluid, in this case, refrigerant, moving through the system. So now you have a high pressure gas that you want to change to a high pressure liquid. And to do that, you need a condenser. And there's a couple different ways you can do it. Some units will have a coil and a fan attached to the actual chiller. And you have an air-cooled condenser right there. Or you may have a water-cooled condenser, which instead of cooling it with air, you're cooling it with water. Or you may have a remote and have the condenser outside with some piping in between. So after the refrigerant leaves the condenser, it's going to go through an expansion device. And again, then it gets changed to that low pressure vapor that does the cooling. So that refrigeration cycle is the exact same as what is in your refrigerator at home, what's in your air conditioning, what's in your car AC. Anything that uses refrigeration uses the exact same refrigeration cycle. It's been the same way for hundreds of years. The only thing that changes about it is the type of refrigerant. So what refrigerant is being used? And in the past few years, that has changed more than it has probably in the previous 80 years. The type of refrigerant has become a hot topic. And as we move to the next slide, the reason for that is these three letters called GWP, which you may hear about. And what GWP stands for is global warming potential. So what the global warming potential is it's a gas's ability to trap solar radiation inside the atmosphere, which is also known as the greenhouse effect. And they made a rating system based on CO2. Carbon dioxide also traps solar radiation, but it has a GWP rating of 1. And then if you look at that red dot that's in the middle there to the left of R290, R290 is propane. Propane has a GWP rating of 3. So propane traps 3 times the amount of solar energy that CO2 would. Now, if you look all the way on the right-hand side of the chart here, actually off the chart, R410A is what most chillers were using for a very long time up until the past recent years. And R410A has a GWP rating of 2088. So over 2,000 times worse than CO2 as far as greenhouse gas is concerned. So that is the big number that has kind of caused a stir and promoted some change. And within the last year, the EPA has issued legislation that requires all chillers to be below 700 GWP before the end of at the end of this year. So you see that dotted line kind of in the middle of the chart there. Everything has to be to the left of that line, and you'll see a couple highlighted refrigerants to the left, one being R454B and the other being R513A. Those are the new refrigerants that ThermalCare has switched all of our products to. And you will notice that R454B has a pink dot, which stands for A2L, which we will talk about in a couple slides. However, R410A is not banned. It is still available and it will still be in use for some time. Let's go to the next slide. The other thing that happened, besides the EPA passing legislation to set a GWP limit of 700, was the AIM Act. The AIM Act was passed in 2019, I believe. And what that does is it mandates a phase down of the amount of high GWP refrigerants, or HFCs, to be produced. So in 2022, they were only able to produce 90% of the R410A that they had produced in 2020. And then starting at the beginning of this year, they're now only allowed to produce 60% of what they were previously producing in 2020. And 5 years from now, they will only be allowed to produce 30%. So by mandating this reduction in supply, the price of 410A is going to get higher and higher. And we've already seen that. So another reason to switch refrigerants. 410A is still available. Units that use 410A can still be recharged with 410A, but we are going to see the price get very expensive here in the next couple of years. Now, I did talk about that pink dot, and if we go to the next slide, we will talk about another acronym, A2L, which you may hear much more about very soon. So R54B is classified, has a safety classification of A2L, and what that means is it is slightly flammable or mildly flammable. R410A is an A1 and considered not flammable. However, if you look at the two pictures at the top here, the way that they measure flammability in refrigerants is They put some refrigerant into a chamber and they light it. And if the flame goes outside that angle there, it is considered flammable. Now, as you can see, there's not a whole lot of difference between a class 1 and a class 2. You can light R410A on fire. Its flame just does not exceed the angle that they chose to be the test. So there's also some other large words and acronyms that they use to describe A2Ls that I'm going to try and simplify here. So yeah, an A2L is considered flammable. However, it has a high lower flammability limit. And what that is the minimum amount of that refrigerant that's required to actually light it on fire. And for R54B, it is a very high threshold. You can see the chart over on the right. If you've been in a college dorm room, you understand that it's pretty small, and you would have to put 46 pounds into that small space before you could even light it on fire. So you need a massive amount of the refrigerant before you can light it on fire. The other thing that A2Ls have is a high minimum ignition energy. What does that mean? It means that it will not light based on a spark or a cigarette butt or sometimes even a match. It needs to be a high ignition source. So not only do you need a lot of it to light it on fire, but you also, it is very hard to actually light it. And then the third part about A2Ls is it has a very slow laminar flame speed, which means it spreads very slowly. So in the unique scenario where you have dumped 20 pounds into a walk-in closet and you're holding a blowtorch, if it does catch on fire, you could still walk away very, very easily without the flame spreading. The spread speed on R54B is 0.2 miles per hour. So most people can walk much faster than that. Most babies can crawl away faster than that. It's not really dangerous, despite having this flammable label associated with it. The other aspect that comes up a lot when talking about A2Ls is A2L sensors. Do we need a sensor to detect when we have a leak? For most scenarios, you do not, because for most scenarios, that sensor will never trigger. If your unit is outside, you do not need a sensor. If your unit is in a large manufacturing space, you do not need a sensor. There are, however, some codes, some building codes, and some other safety measures that require it. So we will provide sensors if needed. However, like you said, for most scenarios, I don't feel comfortable selling someone a sensor that will never go off. So that is kind of my portion there on A2Ls. I've probably rambled on longer than I should have. And now Jason's going to take you guys through a little bit more of the product details and applications.
Thanks, Mike.
Yeah, no problem.
My name's Jason Lehman, like Mike said, the industrial market manager for Thermal Care. Been selling chillers for many, many years, working in applications and applications and sales. So I want to start off with kind of just small along the chillers, kind of cover what is a packaged portable chiller, and kind of how we integrate those into manufacturing. Basically, the difference between a portable and, or I guess we call them portable package chillers, we kind of use them interchangeably. It's when the refrigerant system and the pumping system is all located in one cabin. And typically, a single process load. Occasionally, you'll have one chiller that may control or may cool 2 or 3 smaller machines, but they're not generally used to cool a whole factory of equipment. They're usually only a single circuit. so that if something were to happen to one of the refrigeration components or one of the mechanical components, that chiller would be down until it can be repaired. So usually a lot of times you'll have one chiller for each machine so that you don't lose your whole plant if something happens to the chiller. The operation range for these chillers is typically pretty broad, from 20 to 80 degrees. And they're mostly used for indoor duty, although we're seeing more and more people putting them outside as climate control inside their building is becoming more common. And we don't want to dissipate that heat into the building. And typically, a lot of times they're used for replacements of city water. So you're just not running water through a machine, sending it down the drain. You're basically pumping it to a process. So the pressures are generally similar to city water, 40 to 100 psi. Some processes require up to 300 psi, and we can do that too. The big component, what's the difference between a portable and packaged chiller? If it's on wheels, it's a portable chiller. If it's not on wheels, it's a packaged chiller. That's the big difference between the two. But like I said, the main takeaway here is that it's used to cool a single process load. Thermal Care itself, we build chillers in packaged portable series from 1 ton to about 40 tons. Our NQ series is the most broad of that category. It covers from about 4 tons to 30 tons. In the air-cooled version, that is indoor outdoor, we'll do a water-cooled version. The most important thing to remember is it requires a source of water. So you don't want to use city water for that. It usually has to have a tower system or some way of cooling the water. And we'll kind of cover a little bit when to use water-cooled versus air-cooled versus remote condenser. Remote condenser is, again, 5 to 40 tons. We can build smaller ones as well in a different series. And again, single pump, depending on what size you need. A lot of times we'll have tandem compressors where they're in series, so they're not dual circuit, but they will shut off a compressor for energy savings if the heat load drops below half the total capacity. All these chillers use R454B, the new refrigerant. So that's what we've gone moving forward. And back. The NQ series, what Thermal Care does and what our philosophy is for chillers is we want to be able to have somebody that doesn't know what a chiller is or doesn't work on chillers regularly to be able to walk up, look at it, and know what's going on with the system. So we'll provide a lot of information. Other manufacturers may have a single temperature display, and then if there's an alarm, they get a weird code that they have to look up. So we'll go through a PLC screen that not only has general displays on the main screen, but then you can click through different menus and get all the information about what's running, so that when the system goes down, they can call a service company, get that information. They can call our service department and kind of discuss it over the phone and get it back up and running with a phone call rather than having a service company come out. That's really the attitude we take for all of our equipment across the line. So the next question is, when do you use a chiller? Like I said, we've done 50 different, we're in 50 different industries. I'm sure there's actually more than that. Yesterday I was on sales calls and I went to a company that made saw blades. I went to a company that made coke for blast furnaces. I went to a brewery that uses chillers to cool the beer while they're making it. And we can use them for chemical. Lasers are really common. In your guys' neck of the woods, food and beverage is a really big one. And medical and pharmaceutical. But I mean, there's pretty much every manufacturing process generates heat and needs some way to remove it. Sometimes it's small where they can use air, but most of the time, especially as equipment is becoming more and more sensitive, more and more precise, they need a better way than air to remove heat. And that's where these little packages come in. And there's usually 2 types of cooling that we're doing with these packaged equipment. The first one is we're running water through a machine or a jacketed vessel or some way, and we're taking heat that the machine is generating internally out. We may be cooling bearings that are generating heat from friction. We may be cooling a induction welder or some kind of induction piece of equipment that's using electricity to generate heat, and that needs to be cooled. Or with a laser that's cooling, and so those are typically machines, because they're so sensitive. The manufacturer always gives you the set point on what you need to know. So a lot of times it's best to know the type of piece of equipment that we're cooling, what the manufacturer's requirements are for flow, for temperature, for pressure. And a lot of times they'll even regulate the flow rate through the piece of equipment if as necessary. So if it's running on a lower capacity, lower load, they'll close a valve so they don't have cooling going through it. And basically, if it's any piece of equipment that's designed to run city water through it, a package chiller is gonna save them a lot of water, especially a lot of cities and municipalities don't want continuous water running down the train. Even if they don't charge, or they charge a flat fee, a lot of times they'll come in and basically flag something that is running city water down the drain. So there's hose connections on it. It needs cooling, and generally speaking, it needs a smaller chiller, like a package chiller. You can just drop it in right next to it, wheel in that right next to it, and run. The second type of cooling is we're cooling a product, or we're cooling, and that the product is usually cooled in a tank or in some kind of solution. A lot of times for anodizing, we're cooling an acid tank where they're plating metals. Machine tool, as they're machining different parts, they're cooling the part with a coolant, grinding oil, or fluid. That fluid is taking the heat out of the metal part so it doesn't expand, and then they are basically filtering that and cooling it at the same time. That one as well. Heat treating, they heat the metal up so that it changes the properties of the metal. Then they need to dunk it in a quench tank that again is either water, sometimes oil, sometimes a water polymer solution, and they are basically just need to cool that, maintain that oil temperature at say 90 degrees, so that when they drop the next piece in, it cools at the same rate. In all of these tanks, they basically need to remove the heat and maintain the temperature, sometimes very precisely, sometimes not so precisely. And then we can actually, in our NQ series, we can actually set it up so that we'll monitor the temperature of the tank. Yeah, kind of shown here as a general example. The thermal care chiller will monitor the temperature of the tank, and then control flow through a heat exchanger based on the tank temperature, or in this case, the temperature going back into the tank. If say they want to spray parts with fluid, and they want that temperature to be the same, they'll monitor that temperature. For anodizing, it's generally the temperature probe is usually mounted in the anodizing bath, so that we're measuring the tank temperature so that coding is uniform. That's something you can do. And it's the same process whether you're quenching a fluid and they're dumping heat treated parts into a giant quench tank, machine tool. We're cooling the filter coolants either from the filter tank or directly before it goes to the machine. And a lot of times with this anodizing, because it's acid, you can't run that through the chiller. Same thing with quench fluid, it's dirty. Filtered oil is also dirty, so you want to run it through a heat exchanger. And that's why we do that. And everything uses heat, and it's just a question of removing the heat from the system. And kind of where industrial chillers kind of differ is a lot of times they're dependent on the manufacturer, what space they have available, how they want to set it up. There's no one solution fits all, like for comfort cooling. You really have to, because every manufacturer is different, everybody does things different. So, especially with these portable chillers, because we can do them in so many different configurations, arrangements, we have to know a lot of information about, for an indoor unit. Most importantly, it cools with air. The air has to go somewhere. It's heated up to about 30 degrees. So if their plant is at 85 degrees in the summer, it's going to heat it up to 115, and it's going to put a heat load in their system that could be comparable to a couple home furnaces or even more if they've got a bunch of these. So I mean, it can really heat up a small space or even a large space over time. And then you need some space for that air to be dissipated. It can't just come out the top and be sucked back into the condenser. So it needs to kind of be regulated. And so a lot of places we'll put the chillers outside, or we'll put just the condenser outside. And this is commonly used for a lot of air conditioning facilities because you don't want to put an additional 10 tons or 120,000 BTU heat load back onto your property, into your air conditioner, and your air conditioner has to work harder, your electric bill goes up. So we'll locate the chiller inside so you can have all your water and cooling right at the machine, and the condenser will be located outside. And the refrigerant piping is connected very similarly to a home house air conditioning system. Refrigeration technician comes in, runs the pipe, charges the system, and basically connects communication between the two, and you go from there. As you move forward, some people don't want to have separate systems. Some people can locate the chiller close enough by outside the facility. Then they don't have to deal with the noise of a fan or a compressor or a pump. And they can basically just run it back in. And the big key thing for that is in most of the US, we need to run glycol protect freezing. A lot of times people ask, well, can I heat trace the pipe? Can I put heaters in the tank? And the answer is, while that is possible, it's not a foolproof solution, especially like in a winter storm. It's more and more areas, like recently even in Texas, lost power for a week. A lot of chillers froze up because well, even if it gets cold, it never gets that cold. And so as things change, as long as you can run glycol, it's a foolproof way to get your system to run. And then it's just a question of, hey, are they okay punching holes in the walls, which generally they are, unless it's a lease building. And then, it's in a lot of cases, if they shut down over the weekend and they come in on Monday morning in the middle of February, can their process handle a little bit of glycol that's going to be cold until everything heats up and the system starts to run? And so, I mean, that's basically how to set up for like a process system, and reaching out to us for application information. Thermal Care has a myriad of application engineers, similar to myself, that go over these processes, ask these questions every day, and design systems that are configured for different manufacturers. And a lot of the benefits of our packages, not just for portable chillers, but for all of our chillers, is we're able to do a lot of different applications. The products are manufactured in the U.S. and they're all configured to run across a robust operating range. Minus 20 degrees to 120 degrees, 20 degrees, 80 degrees. It's the same heat. So it's easy to configure it and to do a bunch of different things with a similar component. All our components are available from our service department in the U.S. We stock in the U.S. And a lot of our components are very common, even if you can't get it directly from us. You can really get it from a local industrial supply house. Basically, Thermal Care has been built around for 50 years. We moved a couple times, but been in the Chicago area since 1969. So we're here for the long run. And one of the cool things that has come out in the last few years is we've done variable speed chillers. They're in the package units. These are great for applications where, like brewery, they may make a batch of beer one morning. They need all the cooling that morning when they make that beer for 10 hours. And then the next 3 days, it's just holding that beer at a certain temperature. The heat load is 10% of what the total heat load is. So they're able to cut their energy down 70%. So a typical fixed speed compressor, as you lose capacity, is going to maintain a relatively flat energy usage curve as it drops down. There's a technology called digital scroll compressors, which are pretty good, but they're not as good. And then the variable speed compressors, as you can see, it's almost a line. As your capacity drops down, your energy drops down correspondingly. And you don't have to bang compressors on and off and stage compressors where maybe it drops 5 degrees below the set point, compressor bangs off, goes 5 degrees above the set point, compressor bangs on, it's just turning on and off for years, which can shorten the life of the compressor. It's kind of turning, running your car and slamming on the brakes in traffic. I'd much rather just run at 55 miles an hour and just cruise along and hum along like that.
Jason, I have a question.
Yeah.
Yeah, in conjunction with the variable speed on the chiller, would you want to vary the flow of the fluid through the chiller at that point?
So that's a great question. So you don't really want to vary the flow through the chiller because the compressor is measuring the temperature of the fluid leaving the chiller. As you vary the flow, the temperature sensor can't identify that. So what it does is it's saying, okay, I want to maintain this temperature. If you cut the flow in half, well, that's basically cutting the heat load in half, and the compressors won't recognize that, so it'll continue to it'll overcool, your temperature will drop, and then the PID in the controller will react, and so you'll kind of whiplash a little bit. You generally want to keep a constant flow through the chiller, and that'll allow you to maintain a tighter temperature range, which most manufacturers, that's what they're looking for, is tighter temperature, not fluctuation, so that fluctuations create variability creates bad products.
Good to know. Thank you.
Yeah. Great question. And then along the same vein is our central chillers. Central chillers are generally much bigger. A lot of times they are dual refrigerant circuits. They're designed to cool a plant of injection molding machines or a plant of lasers or anything where there's a large amount of machines. They're multi-circuit or in a lot of cases multi-unit, where maybe you'll have 3 or 4, so that if something happens to a compressor, your entire facility is not down. And then they're tied in with a pumping system as well. Kind of like along the same lines as what Mikey talked about, they're not just a chiller, there's usually a pumping system, depending on what heat load you need. Some people can get away with water in the 90s, so they may use a tower system for that, and then cool a water cooled chiller, and then use chilled water for the heat loads that require colder water. Very common in plastics where you're cooling hydraulics or presses with 85-degree water, and then cooling your chillers with that 85-degree water, then cooling the actual molds or more precise units with chilled water. So we'll do drawings and piping schematics and kind of work with companies on the entire system. We've got a couple different variations of our chillers. This is our most common in a lot of cases. We use these for large process loads, factories. A lot of times we can be a single process load depending on if it's big enough. This is our KSC. Probably looks to a lot of you guys like a commercial chiller, where it's talking to where the main differences are. But yeah, it's got our same advanced controls so that the plant operator can walk up to it, see what's going on, see what they need to see, and can be troubleshot very quickly without a refrigeration or an HVAC tech present. A lot of the KSCs has a wide operating range. So these can run from -20 to 125. So the big thing is commercial chillers. They do one thing really well. They make 44-degree water on a 95-degree ambient day, and they run. And that's great. And if you need that, they're great for it. But if you need to run in February and it's 0 degrees outside and you need 60-degree water or you need 30-degree water, that's where these systems really come into a lot more applications. We also have, we can provide a pumping system on the back, so we put everything outside. It's one package. There's multiple refrigeration circuits, and they can be run together. They can also, and I'm going to get into the free cooling as well here shortly. But yeah, so say you have 3 machines, or say you want 3 machines, so that if one chiller goes down, they can basically run 2 chillers, and you still have 60% of your capacity. We can daisy chain them together so that they're able to run and switch over without an operator having to come out and change. A little more just kind of into our free cooling, our interval pumping system, where basically we'll have a holding tank, a buffer tank that ships separately, but basically aligns with the chiller so that when it's installed, you basically just made up the piping. And run, there's a wire and whip already included, so you can just connect that right to the pumps. So you don't have to spend money piping in between the units. And there's a standby pump and that has on-max switchover as well. Everything's designed to basically, if something happens, at least initially, you're able to run at least partially load. That's kind of one of the things with industrial cooling. It needs to run, and it needs to run reliably. If it doesn't, it needs to be able to at least run long enough so people don't lose all of their production. And then with all of our systems, in our controls, we can do free cooling systems. And what a free cooling system is when the ambient temperature drops 10 degrees below the set point temperature of the chiller. So maybe if the set point temperature is 60 degrees, whenever the ambient temperature is 50 degrees, instead of using compressor cooling, which is expensive, 1 ton of compressor cooling may need 25 horsepower, or 1 horsepower of heat. So 25 tons would need 25 horsepower of heat. You can maybe get away with cooling it with air, where 25 tons may need 3 horsepower of fan. So you're saving that energy continuously year round. Again, the system is designed to switch over from compressor cooling to free cooling automatically. Additionally, in that if the ambient is within that 10-degree band, then we will run the free cooler to drive the temperature of the fluid down, so that you're using fewer compressors and less energy when it's in that band. Additionally to KSC, we have indoor central chillers as well. The TSC, our series, is our plant-wide system. It's available in water-cooled, air-cooled, remote condenser, like our package units. They're designed to be located inside. They're mostly dual circuit, although we do have single circuits available. The TSC also will do a package unit with the TSC where it has 1 pump and 1 tank. Excuse me, 1 pump to send out the process and a recirculation pump that pumps through the chiller and back. So it's ease of installation. You don't have to run piping between the tank and chiller. So there's in this case, because we have 2 separate pumps, one pump is running through the chiller for continuous flow. We can actually then put a variable speed drive on the process pump and regulate the flow out to the process. Generally, we do that based on pressure. We basically maintain a header pressure of, say, 70 psi or whatever you need it to be, and regulate the flow and the speed of the pump with the VFD back. And then our final chiller, central chiller product that we use is what we call our TC. And what that is it is it uses a variable speed centrifugal compressor. If anyone's familiar with it, it's the Danfoss quote unquote turbo core. It's actually a really cool design in that it's got a single moving part, which is the shaft shown here, and then it rotates the shaft using magnetic bearings up to about 36,000 RPM, and it has soft starter and a inverter speed control to regulate the refrigerant flow through the system for energy savings. ThermalCare is one of the first companies in the U.S. to do this. We started this in about 2005, so we've been working with this for 20 years. And we've made some modifications to our chillers along the way. So it's a really neat product. It's also a low noise level product. A lot of times, if you're in a factory or if you're even running in our test stand, you can't even hear the compressors running. You put your hand on it to feel a little bit of vibration just to see. And so we'll do air cooled, water cooled for those. A lot of times they are single units, but we can also do dual circuit with units as well. And the main thing is these require a little more because of the magnetic bearings. They require a little more temperature stability, so we'll usually have a larger buffer tank, or for some applications it may not be a good fit, but if it is, it's a great way to save energy. And then we have a variation on that where basically we take our energy efficient design that has a high ER already, and we basically use a hybrid evaporator to raise the ER from 25 to 31. It drops the the energy usage from about basically 0.5 to 0.4 kilowatt a ton. But when you're talking over 100 tons of cooling or 120 tons of cooling, that kilowatts, is fairly significant. 12 kilowatts continuously over time. These are great if you're retro. There's one size, unfortunately, it's 125 tons, just the way it works, and they're great when you want to retrofit a system that's already there because they're nice and small. They're 37 inches in width, so they can easily be moved around. And this technology is really cool, reliable. We actually have, we're using it to cool ice rinks at a lot of community centers, and we're partnering with the NHL, some of their community rooms as well. So it's a robust design, and it's really a kind of a neat way to save energy. Just kind of go more into the just in case anybody's interested, the hybrid film evaporator. If you're familiar with a flooded evaporator, where the refrigerant pools inside the evaporator, this is a little different. The refrigerant basically pools around the coil and then evaporates. So you're using all of the coil all the time when you need to. So it's a pretty neat design, and it really drastically reduces the energy efficiency. And so basically, as you can see, if you look at a fixed speed energy chiller where you're staging, the blue line is where you're staging compressors. And so you're turning off compressors. If you were to use a flooded evaporator with staging compressors, you could save a little bit of energy. Then when you compare it to our regular CC series of variable speed chiller, you can see you start running 50% of your load, you're saving a lot of energy. And then the variable speed centrifugal compressor saves a lot at the higher end, but it's a significant energy savings over time. And when you think about it, like most plant facilities, they size for worst case scenario or for growth. Most of the time they're running at the 50% mark, or they're running at the 75% mark. For air conditioning, it may be a little different, but they're mostly running at the 75 and 50% mark, and that's where you see a lot of energy savings for HVAC. an hour-long presentation, so I just kind of wanted to give you guys some time for some questions. Have any? So
I don't see any in the chat box. Any questions about any of the things we've discussed? Please put them into the chat box now. And I guess we can keep going. You got about 5 minutes, Jason, so.
yeah, so I mean, there's a couple other products that we offer. And one of them is cooling towers. I probably don't need to tell this group this, but I always preface this because everybody wants to put the cooling towers inside for some reason, but you don't want to kill people or turn your plant into a jungle. So let's not do that. But basically how a cooling tower works is, and these are a couple of our cooling towers. Water comes in the top. It's through the inlet here. There are nozzles that distribute it through fill, which is plastic that has a lot of surface area. There's a fan up here that pulls the air up, and the water evaporates off the fill, cools the rest of the water. It's like getting out of the shower and having somebody blow a fan on you. You get really cold because the water's evaporating off your skin, pulling heat there. Our FT series is a round tower that is multi-piece construction on the basin. And it's our economical offering. When you get into larger towers or FC, it's a single point basin. Fiberglass is manufactured by a boat manufacturer up in Wisconsin, so it's very durable. 10-year warranty. I don't think we've ever replaced a shell in at least the 25 years that I'm aware of. So it's one of those products that's really long term. It's got nice drift inlet air filters, so it keeps the amount of debris, leaves, small animals out of your tower water, which is always nice. And all the construction on our tower is all stainless steel components, plastic or PVC. If you're familiar with galvanized towers, they eventually just rot. These towers, they're going to be here. I started with Thermal Care back in '98, and towers that I sold back in '98 are still running. It's not a sale that you get like a lot of replacement opportunities because they just sit on them, and you don't want to because they sit on the roof or they sit somewhere where they're just hard to move around.
We did have some questions, Jason, that popped up. On chiller, what range of chiller capacities do you have? And how quickly does the chiller respond to changes in load?
So, yeah, great question. So basically on our package units, we range from 1 ton to 40 tons. On our central systems, we range from frankly 10 tons to about 240 tons for our TS series. And then the KSEA series ranges from 40 tons to about 120 tons. The TurboCore series is roughly 60 to 120 tons.
However, you can also daisy chain chillers together up to 720 tons.
Yeah.
Yeah, another question here, buffer tanks, is there a minimum loop volume? And do you require buffer tanks?
Yes, we do. Buffer tanks for process, it's good practice to be somewhere in the 6 to 10 gallons per ton range. And the reason for that is the chillers have hot gas and they will react. But especially on the TurboCore chillers, you do want a larger buffer tank because you want the water flow going into the chiller to be more stable. The more stable that is, the more stable that will come out. We do have capacity control, hot gas bypass in a lot of our chillers that will react. But with any kind of PID control, what comes in affects what's going out, and so it's easier for the PID to react and create a stable temperature if what's coming in is stable. The last thing you want to do is have your temperature all of a sudden drop rapidly or or say it rises rapidly, compressor runs 100%, and then the temperature coming in drops rapidly. And now the compressor's running 100%, it drives the temperature of the fluid down, cycles off, and then it comes back up again, but now your compressor's in an anti-cycle state. Because you don't want to have compressors turn on, turn off, turn on, turn off, and that's how you burn up compressors. So you really want to allow for some stability coming in.
And with your PID control, how precise can you get on your supply temperature?
Generally speaking, you can. That's kind of a loaded question because
Yeah, it is.
How steady your steady state is. A lot of times we're plus or minus 2 degrees, plus or minus a degree. Anything less than that, you're really at the mercy of the temperature probe precision and accuracy. So I would say, if we can get away with plus or minus 2, we can do that all day. Plus or minus 1 Fahrenheit is possible, but that really is more process dependent.
Great, thanks.
And then just to kind of close out the product offering line, so a lot of times we'll do our own pump tanks. We'll make them out of stainless steel or fiberglass. And we'll do a lot of different variations where we'll have a single well, double well that's partially divided, or a double well that's fully divided. A lot of times we'll do for plant-wide systems, kind of falling back to what I was talking about earlier, where one pump goes through the process and then one pump goes through the chillers or the tower. And that allows us to keep constant flow through the chiller, get better temperature stability, better capacity control, and then send the water out to the process where if the flow rates change, the chiller or the tower doesn't see that. And then our controls on our pump tank, even if we're doing, we're not communicating with the chiller, we're using some other chiller, we can do free cooling systems with it. We can do tower control with it. A lot of times, especially in areas where there's freezing with cooling towers, because you want your cooling tower to run in the winter because it's a process, we need to control the cooling tower fan and also the cooling tower pump so that we're not sending water out to a cooling tower that's 40 degrees when the cooling tower is in minus 20 degree ambient conditions and freezing up the tower. So basically what we'll do is we'll basically stage the fans or put a VFD on the fans to control that. And then when the water temperature doesn't get cool, we'll actually turn off the cooling tower pump, have all the water drain back inside until we start sending the water back out to the pump. And then we'll do pump decks, hydronic packages. A lot of times we'll do a whole deck configuration where people don't want to do all the installation. We'll do a fully divided tank, so maybe you're running water on one side, glycol on the other, and we'll control the water temperature according to the process, the flow rate according to the process through our PLC, remove the heat from the process water with a plate for the heat exchanger. That way. And again, we'll do plant-wide systems. This is a pretty common example where we have dual tanks for a cooling tower system. So we're sending 90-degree water to some processes, using that to cool water-cooled condensers, and then sending 50-degree water to wherever it needs to be. A lot of times, like I said, injection molding, machine tool, dairies, whatever, is what we'll use it for. And so we can supply all the different components, filters, cooling towers, everything you need for your industrial process, with the exception of the piping. That's usually done best by a local HVAC, a local contractor, and most people have these. With that, that's pretty much everything I had. If there's any more questions, I'd be happy to answer them.
I think you've got all the ones that I had, Jason.
Yep.
Great. We appreciate your presentation and your knowledge about the systems. thanks everyone for joining. Now, if you have any applications that you'd like to have us look at, get with your Hurley representative and we'll get you in touch with the right people at Thermal Care to get your application done correctly. Mike, is this presentation available to share with our customers or the people who attended?
Yeah, I think we can do that.
Okay. As long as that's available, then we can get that out to them. I guess that, and with no other questions, we'd like to thank Mike and Jason for the presentation and for their time and effort here, and for everyone attending. The winner of the drawing today is Lawson Close from JRT Mechanical. He works out in the Tri-Cities area. Lawson will get Kennedy in touch with you and get you your Yeti cooler for attending today. And once again, thanks everyone for presenting and for everyone attending. And we appreciate your time today. Everyone have the great rest of your day. Thanks again, Mike, Jason.
Thank you.
See ya.
Thanks, everyone.